Heat Lab, everybody. On the bench this weekend I have a Dynaco PAS tube type preamp that came in for repair about 6 months ago. I'm just now getting to it, alright? Anyway, let me show you the hit list of what the customers want me to do. We'll dive into it and get her going. First off, he purchased one of the SDS capacitor boards, and it's in there but not wired up, so he wants me to take care of that. He noticed a burn mark on the top of the power transformer, wants me to investigate that and see if it needs to be replaced. I hope not, because if you guys take a look on Triode Electronics site, the PAS 211 power transformer has been discontinued. So they're a rarity now. Obviously, to acquire something as a good OEM replacement, we're probably going to have to get another preamp, so that would not be a good thing. So he told me to go through it, check the boards, eliminate the quad filter cap if necessary, and do the updates that I normally do on my videos. So let's take a look at it. We'll check that power transformer and move forward. Okay, here's a inside view of the PAS. You can see that SDS Cap Board up here about 1.5 inches off the chassis. I plan to lower that and secure the mounting. Power transformer here, leads in the breeze, so that'll be easy to verify if it's okay before I wire it. He did install a new RCA jack panel assembly, and the soldering on all that looks good, but I'll trace that out to make sure it's going where it's supposed to. Got some scotch tape here over these tube sockets, and I believe the reason is this chassis has been spray painted with silver, and there's overspray on the circuit boards, and it's loose. See there? Just kind of falls right off. So I'm going to need to clean that up, and then of course verify the operation of these boards. Here's a filter cap that he gave me the option to change if I needed to, but the other thing I noted is he sent another potentiometer. Reading through his notes, he said that the left base control may be defective. So I got in here and I was peeking around, and if you take a look at that pot, if I can hold this thing up, get it to where it doesn't fall over. Okay, so if you take a look right there, that lead was never soldered. This was obviously a kit, and that was overlooked. So that may make it appear as though the pot's bad, but I bet you it's okay. This volume pot, I don't think that's original, but I have seen this type of pot used in the past. We'll check that too. And of course, the good old wafer switch. This is one of the main violators for cutouts and poor performance of this guy. I hope that's good. We'll verify all that after I repair the power supply. So the owner also installed one of these nifty new LED power indicators, and that is supposed to take some of the stress off of the 12-volt supply that feeds the tube filaments. So here is the wiring, which you can see has been extended, and it's got some electrical tape. I'm going to go ahead and clean that up, and if we need to extend the wires, I'll use some heat shrink tubing. So the first thing we're going to do is check that power transformer. I've had a lot of these that have failed over the years, and luckily I was always able to buy a replacement, but that option appears to be going away, so let's hope it's good. So I got my meter set up on AC volts, and we're going to look at the high voltage first, and I'm going to come up on the variac and I'm just going to bump this. I do not need to see full power, I just need to see if it's alive. So here we go. You can see there we've got output on the high voltage line, but that appears to be low. So I'm at about 50 volts. I've only seen about 15 volts output of the transformer for the high voltage. Not a good thing. Alright, let's check the center tap. So we'll just go center tap to one of the highs here. Watching our meter. Here we go. Yeah, same thing. She's low. Okay. Let's take a look at the filament supply, which is on top. And that should be about 12 volts, hopefully, right? So if you take a look at your diagram, that's the blue windings. Take my range, get down to where we'd see 12 volts AC. Okay, bring her up. Oh boy. So there's 50 volts applied and I got like 0.3 volts. So we go to 100. I'm only getting a volt. Power transformer appears to be toast. But luckily, I have an old stock unit that was pulled. So let's hook that up and check it. And if it's good, it's going in. So I sat here and thought about this situation for a little bit, and it kind of reminded me of something that had happened to me in the past with one of these units. You know, the Dynaco PAS has a power switch on front, of course, and that power switch also is the switch power for these AC outlets which turn on your amplifiers. Okay, so there's quite a bit of current draw on those amps, say an amp and a half to 2 amps a piece, right? Well, this little front panel switch is only rated for 3 amps. So I thought, could the power switch be bad? And it's making it look like that power transformer is bad. So I thought, you know, I better double check that. Don't want to make the mistake of putting in a transformer when I don't have to, right? So here is power switch. Alright, so it appears as though the switch is alive, but what I'd like to do is make sure that we're seeing that primary winding here on the cord. I am, but I've got like 50 ohms of resistance, and look, this power cord has got some issues. So it doesn't look like it's the switch, but possibly this power cord's messing with me. So I'm going to bypass that and we'll apply power direct with the variac and see if that transformer is actually okay. If so, you almost got me, Dynaco. Okay, here we go. Same test. I'm looking at the high voltage that goes to the rectifier tube. Bring it up on the variac. Looky there, guys. I've got high voltage. We didn't have that before. It's a stupid power cord. Alright, let's go up and take a look at that 12 volt winding. Because we got high voltage, so we probably have the 12 volts too. Wouldn't that be cool? Alright. Step around here. I'm going to walk around my camera. Get back on these blue wires. Okay. Alright, here we go. Plug her back in. Let's bring it up. Looky there. Alright, I'm up to about 100 volts right there. You see we've got our 12. That's all it was. Lesson learned. Check the power cord. Don't change your transformer. Alright, so super good news there. Man, it's a good thing I took the additional time to kind of think that out before I removed a power transformer and replaced something that wasn't necessary. It'd be a very bad move. Alright, so what I'm going to do next is go ahead and reposition this power supply board. Another thing that I don't like is having the AC power on the same board that's trying to provide clean DC to the circuitry. So I am not going to use the fuse holder in this position. I'm going to add a chassis mount one over here. We'll keep the AC over here and the DC over there. Alright, let's get going. Alright, so I've made a little hole here to mount our little fuse holder. This is for the AC line, so the power will come up, hit it, go right back under the chassis, rather than stringing it across the chassis to the power supply board. Also cut that stud down and added a large aluminum spacer. And now the board will sit nice and secure, and it's not so high up on the chassis. And it also allows me enough room for wiring. It's going to come together well. I installed the new power cord, and you'll notice this is a standard 2-conductor power cord, non-polarized. Those blades are the same. You have to reinstall the same type of 2-prong power cord. Do not hook up a 3-prong cord with ground to these preamps, or you'll introduce all kinds of hum and you'll wonder what the heck is going on. I've got bottom side tidied up. I color coded the wiring to make it easier to hook up the power supply board. Also took care of that mess of the extended wires going to the indicator lamp. Used some twisted pair gray 22, and the rectifier tube is a blue and black twisted pair, which will meet up with the blue twisted pair off of the power transformer. Also, just to avoid some confusion. Alright, let's go to the top side and get that board installed. So the DC board is wired up. The trickiest part is, if you come in bottom side like I did here, is making a few of those solder connections. These wires are short. It can be done, but you gotta take your time. This green wire here is our ground runner, so after I seat the board down on the mount, that's going to solder right here on the chassis. Alright, last connection is the ground runner. It's a pretty heavy duty connection. It requires a special soldering iron. Can you guess what that is? That's right, Snowzoramas on the job.
A lot of people wonder where ghouls come from. Well, they come from all over. They have a lot of ghouls come from Portugal.
Alright, before you plug this thing in, before you install tubes, you want to make sure there's no shorts on this new DC board. Okay? Everything on that board is floating except for the main ground point. Okay? That goes to the ground runner, which is the negative for all the filter caps. Everything else, you see our little leads poking up, every other lead will be floating. If you see any shorts on the points where you brought in the wires, you have a problem. Do not power it up. Find out what's causing those shorts and clear it. Alright, so now we're going to check the high voltage. So I'm looking at the output of the 12x4 tube coming to the filter caps. Right? Once again, we are not going to bring this up to full voltage because it's not loaded, and I do not want to damage the power supply board. So I'm bringing it up on a variac, nice and slow, until we start hopefully seeing DC voltage. Now I'm watching my current. Everything looks great, but we want that guy to start moving. So there is about 60 volts applied. Nothing yet. Okay, go up to about 70. Remember, we got to heat up that filament. Here she comes. So you can see that's our high voltage ramping up. That's a good thing. That's all I need to see. I'm going to bring it back down. And now, of course, there's nothing loading that power supply besides my meter. So we'll want to discharge that before we move on. So this is a 25K resistor. I just keep around the shop. Make sure I unplug it, of course. And we'll just kind of put her there and let it pull that voltage down. Even though it's, you know, say 20-30 volts, it could kind of scare you if it discharged. Alright, so that's safe. Now what I want to do is we're going to look at the DC volt feed that's going to the tube filaments. Make sure that's there, and if so, pop in the tubes. Alright, so I've already connected, but the Dynaco is actually unplugged. Remember when I brought up the high voltage, it also charged up the voltage for the filament supply, and there it is, 18 volts unloaded, right? So I'm sure if I plugged in 12AX7 here, remember it's going to take both because it drops that voltage across the two tubes. She discharges. Good to go. And there she is powered up. That new blue LED power indicator. And you can see the filaments on, at least on the rectifier tube. No smoke. Good deal. Next thing I need to do is get a signal through it. Alright, so we're going to take a mission complete on the power supply repair of the Dynaco PAS Preamp. That was the intent of this video. If you want to see more details on how to install that preamp board and do the wiring underneath, I have other videos on that subject. In part 2, we'll inject a signal, we'll see how the preamp is performing, and we're probably going to replace this base pod because he was correct, there's something mechanically wrong with it. So we'll see you in part 2. Thanks for tuning in to D-Lab Electronics.